Section 6.6, Steps and Lines. The purpose of this section is to draw attention to some of the more subtle aspects of math that many students overlook. Math is not just about performing the calculations, but also the ability to explain the calculations you did and understand why they work. A line of work is a collection of symbols that are written after an equal sign. For example, this is the first line of work in this problem. This is the second line of work. And so on, moving down the page. This is one of the reasons why we emphasize keeping the equal signs lined up and working down the page. It helps to very clearly distinguish what's going on here. A step is a mental process that happens in between the lines of work. You don't actually see the steps written out, you see the results of steps being written out. So for example, going from here to here is the first step of the calculation, and something happened. Going from here to here is the second step. And then this is the third step. Sometimes you'll see steps explained in the far right-hand column, just as we did with the order of operation problems. An important intellectual skill to have is the ability to describe the steps of a calculation. This is where you can show that you really understand mathematics. For example, in this calculation, the first step involves us rewriting the integer as a fraction. And you can see that the 2 right here became a 2 over 1 right here. And this was the thing that changed, and the words rewrite the integer as a fraction describes what happened. From here to here, we are rewriting with a common denominator. And this is something that we have to do for every single addition and subtraction problem that we have with fractions. Embedded within this step is the determination of what that denominator would be. Now in this case it's not very hard to see that's going to be a 3, but it is there as part of that step as well. This step is just simplifying, which is we're multiplying the 2 and the 3 together to get 6 and the 1 and 3 together to get 3. And then we actually do the subtraction, which is another simplification step. And that completes the calculation. Once you have the ability to explain the steps of a calculation, you actually have access to the tools that you need to work out many types of problems. For example, one of the tools that we had in this problem was that we rewrote an integer as a fraction. And that was when we changed a 2 into a 2 over 1. This is something that we could do for any calculation. We did it for subtraction here, but if you recall, we also did this for multiplication, division, and addition as well. Another step we had was to rewrite the fractions with a common denominator. And for this, we took the 2 over 1, and we rewrote it as 2 times 3 over 1 times 3. This step is something that's limited to addition and subtraction. We don't do this with multiplication and division. And so being aware of the different types of steps you can take for different types of problems, you can help keep yourself from becoming confused. These are not the only steps that we have in mathematics. For example, we have FOIL and the distributive property. And we also have manipulations that you haven't seen yet, such as combining like terms, we also have a technique known as completing the square, and there are many others. As we go further in this class, you will learn more and more different steps you can take to manipulate an equation or an expression, and then learning how these interact with each other and when to do them becomes the important skill. Section 6.7, Variables. A variable is a symbol that represents a value. The types of variables we will see in this class are usually letters like x and y and t, but it turns out that variables can be basically any symbol that we want. letters, Greek letters, and any other symbols that we decide that we want to use. A monomial is a number, a variable, or a product of numbers and variables. So for example, 3 times x is a monomial. 3 times x times x times x times y is a monomial. But we usually don't write it this way. We use exponents, 3x cubed y squared. We can also have a number by itself as a monomial, or a variable by itself as a monomial. Monomials have two different parts, the coefficient, which is the number part, and the variable part. So for example, if we look at 3x, 3 is the coefficient, and x is the variable part. If we take the more complicated expression, 3x cubed y squared, the 3 is still the coefficient, and the variable part is the entire collection of variables. So the variable part of this would be x cubed y squared. Now there is a special case to be aware of, which is when you have a variable by itself, such as z. The coefficient of this is actually a 1. We call this an implied coefficient because z is the same as 1 times z. And later on we'll see another reason why this 1 becomes important. A binomial is a sum or difference of two monomials. For example, x plus 2y is the sum of x and 2y, and x and 2y are both monomials, so this would be a binomial. We can also have a difference of monomials, such as 3a minus 2b. The reason why we still count this as a monomial is because we can use addition of the opposite to write subtraction as a sum. The sign of a term is always determined by the symbol to the left of it. We saw this when we were doing FOIL with subtraction. For example, with 3a minus 2b, we would say that the first monomial is 3a, and that the second monomial is negative 2b. The negative sign stays with the term to the right. A polynomial is the generic term for a sum or difference of monomials. This could be 1, 2, 3, 4, 5, 6, or even more monomials in the expression. Example, rewrite the polynomial 2x cubed minus 3x squared plus x minus 12 as a sum and determine the number of terms. 2x cubed minus 3x squared plus x minus 12. Subtraction is addition of the opposite, so we're going to apply that at every step we need to. 2x cubed plus negative 3x squared plus x plus negative 12. The terms are the parts that are separated by the plus sign. So in this case, there are 4 terms.